I've got this old hard disk. So this is an old IDE hard disk. I had this in a NAS drive years ago, and it's just been in a box somewhere. I kept it in case I found another use for it one day, but this is 320 gigabytes. So now, I mean, typically when you buy a new hard disk, you buy one 10 times the size, and actually just today I saw that you can now buy a USB stick that's got 256 gigabyte capacity for about £70. So really, in terms of, you know, size and, you know, interface, this device is not really useful any longer. So I thought I might as well take it apart. I've taken several of these things apart before, but I thought it might be interesting if you've never seen inside one of these, you've never actually taken one apart yourself. I'll show you how it's done and what's inside. Now usually they're secured with some kind of special screw, so in this case it's a Torx, and luckily I have a small Torx screwdriver, so it's not too much of a challenge for me to take these apart. You'll find there's a number of these to open up. I have to say Merry Christmas and thanks very much to my great old friend Stuart, who gave me some screwdrivers for Christmas. This is a real sort of high quality treat compared to what I have been using for small Torx screws. So good on you, Stu. Right, so on the face of it that's all the screws, but usually they've hidden one in here somewhere. So I can see there's a little kind of foil circle here, so I suspect there's another screw hidden under here also. So we'll just go in here with the knife. There we go, there's one hiding under there. So I guess they do this so that they know if it's been tampered with, because you've ruined the label. Because you're not supposed to open these up, you know, they're sealed against dust. I'm not sure if they put an inert gas inside them. Maybe if you know, you could say down in the comments below. But they certainly try and keep them dust free, because the dust particles are very big in comparison to the height that the read-write heads fly over the top of the hard disk. So these are normally a bit challenging to open there, so you have to break a seal here. There we go, so there's a bit of a crack as it opens up. There you go, so the disc is open. You see there's some kind of like filter or dust trap or something, and there's a hole there, so I don't know if they use this to evacuate it, not sure. But anyway, the lid's off and we're in. So you can see the main components of the hard disk. So you've got the platters themselves on this spindle, and as you'll see in a minute, there's a motor underneath built into the casing. You can just see the back of the brushless DC motor there. and these are the read-write heads, so I think that's parked in a safe position at the moment, but during normal operation this thing will be hunting backwards and forwards across the surface of the disk. So because the data is organized in circular tracks around the disk, so this needs to hunt to a particular track, and then it will sit there reading the data that comes underneath as the disk spins. Not sure what that is. There's a little kind of spindle there. But we can take it apart further. So normally this thing here, so in order to move the head backwards and forwards, this has got a coil on the back. We'll open it up in a second. And so by energizing the coil, they move this back and forth relative to the magnets here. So there's some neodymium magnets. So if you want some strong magnets inside a hard disk, is one place to find them. So let's take off this assembly and get the magnet and the keeper out. So more of these Torx screws. We should be able to lift that off. It's very strong. The magnet's very strong. And there we go. So now you can see there's a coil on the back of the assembly here. So that can move backwards and forwards, and that's going to move when the coil is powered up. It can move relative to the magnet. So that's the basic seeking mechanism of the hard disk head. And if we well, let's take that assembly off. So let's take off the read-write head. Oh, it's hard to get off. A couple more of these Torx screws. You see where I lift that off there, so there's a flat flex here that's connecting several wires into the read-write head, and if you look down there, there's a little hole in the casing, so the connections here can press against the back of the circuit board. So on the back here you've got the controller circuit board. I'll talk a bit about the controller in a minute. So obviously that's sealed in there also. We should be able to lift this out, I think. I don't think they're usually fastened. I don't know, I think I might have to take the spindle off before we get to that, because I can't see a way that lifts up at the moment. Alright, so let's take this thing off here. So I'm not expecting this to go back together again. Well, that's interesting, because you can see here this is a bit of a clue to the structure of the platters. You see, so a disc platter fits in between those combs there. So you can see that we've got multiple disc platters on the cylinder. Okay, well, I'll take the platter off so that we can see. Oh, that's a smaller size. Get the smaller Torx in there. Okay. Yeah. yeah, so as I say, I'm not expecting this to go back together again, and I've heard that generally you shouldn't take the top of a hard disk and then try and reassemble it after, because the dust gets in and then basically you can damage the surface of the disk. So although I have heard of people doing it, you know, sometimes these jam on somewhere on the surface here, and then I've heard of people opening it up and unjamming the read-write head, and then just trying to do one last backup of the disk, because, you know, once the disk has been opened, it's not going to live very long. It's not going to live very long, but it might be that you can, you know, you can save the data on the disk. You know, which is, if you haven't taken a backup of any kind, maybe that's your last chance to recover photographs that you care about and so on. But really, I would totally recommend taking backups, and don't wait for the hard disk to pack in before you try and save your data. Right, so then we get to explore the platters. Let's see if I can get this off now. Yeah, okay, so let's put that to one side for a second, and we'll have a look at this. Got the read-write heads. There are 3 platters, and you remember, so that the top platter, you could see the top of this head over the top of one platter here. So you got one platter in here, you got a second one here, and a third one here. So that means you got 2 platters where you can read both the bottom side and the top side, and then finally the one on the bottom you can only read the top side. So there's 5 surfaces that you can read. So obviously these are very delicate read-write heads. They're designed to fly on a cushion of air above the surface of the hard disk, but very, very close to the top of the hard disk. And these are electromagnetic heads like you might have found in a cassette player long ago. And so each one of those is wired so that down this flat flex here you can get an electrical signal through to the circuit board, and then the circuit board has got amplifiers on it so that you can boost up the tiny electromagnetic signal and turn it back into a stream of bits so that you can read the data back. And you can also see much clearer now that this coil that's built into the, you know, the heel of this assembly. So that's the electromagnetic coil that allows it to navigate its way backwards and forwards across the neodymium magnet. And, you know, in this flat flex also you'll have the wires, probably the thicker ones in here. If you look, there's various thicknesses in the flat flex, but the thicker ones are probably for supplying the current to activate these electromagnets. Actually, one more thing about the read-write heads, you can actually see there's a little chip actually built into the assembly here, so you can see all the pairs of wires coming in from the heads on here. They all track into this little chip, which is actually part of this flat flex, this flexible PCB, and then there are some more wires coming out the other side. So I imagine this is like a, you know, analog amplifier to amplify the signal off here, maybe you know, improve the signal, make the signals more suitable for digital, and then the longer cable going back to the PCB, you could have the more robust signals travelling down here. That's what I imagine it is anyway. And then you've got the hard disks themselves. So Now I've undone the screws, you can actually get the platters out. So each one in between, you've got these little aluminium rings. If I can tease this one out. Let's just tip those out. So you've got these spacer rings, and you've got the platters themselves. So here we've got 3 different disc platters, you know, which are normally riding a small distance apart. If I put that ring back in again, put the spacer ring back in, you can see there's a small distance in there, just enough space to get that read-write head in between. So I'm not sure what they make these out of, but they're obviously coated in some kind of electromagnetic, you know, magnetizable material. Make quite a metallic noise when you bang them. Obviously I'll wave a magnet over those before I throw them away in case I've left any valuable data on there. And what's left in here? Well, we've got another neodymium magnet assembly at the bottom. So let's see, it's quite strong. If you put them face to face like that, it's almost impossible to get them apart. So there we go, that's nearly everything. I mean, there's a bit of plastic assembly here. See if that's, should be able to crack that open as well. I'm not exactly sure what the function of that is. And then the rest of it, so what have we got left? We've got the circuit board on the back, we've got the brushless DC motor, and you see you can pull the 3 torque screws out of there, and you can get the motor out of there. I've got one actually that I took out of a different disc, which is obviously very similar. So you can see the structure of the brushless motor. There's the central spindle, and then on the back here you can see there are 4 connectors, and so there's actually 3 coils in here, and you need quite a sophisticated piece of drive circuitry in order to spin these round, because these don't require much, don't need to generate much torque, because the platter assembly is quite light, but they do need to go very fast, and so this is what a brushless motor is very good at. I'm not going to try and drive the motor today, but you can find various videos on YouTube where people have built circuitry to drive a brushless motor, or you can actually turn them into a generator as well. So you can, you know, like if you put a fan on here, you could get the wind to turn it, and with an assembly of diodes you can actually generate some electricity and generate some DC and turn it into a generator. That's quite interesting actually, the way these things are wired. So if I just quickly sketch what it looks like. They've got 3 coils like this, and one of the pins, say pin number 1, will be the common ground between all of them, and then the other pins 2, 3, 4 are connected to the coils, and by activating the coils in the correct sequence, this is how it gets the motor to turn. Anyway, that's probably for another video. So what's left? I'm going to leave that in there, because I might actually try and power it up in another video, see if I can drive it or use it as a generator or whatever. But I could take the circuit board off. So yeah, the circuit board, there's a lot of stuff on here actually, because obviously it's got the circuitry to drive the brushless motor. It's got some analog electronics to boost up the signal from the read-write head so that you can recover the data from it. And it's got the logic to power the electromagnet and move the read-write head around. But then also, importantly, it has the logic that it needs in order to interface with the computer. So the IDE interface, you know, is a standard way of connecting a hard disk to a computer. So when you connect in the hard disk, it knows how to talk to these chips, and the chips will actually say things back. You know, it'll say what's the capacity of the disk, how many cylinders are available in the disk, and so on. And so there's a lot of sophistication built into these circuit boards. And as you can see, it's all surface mounts. There's a very high density of you know, different chips for different purposes here. 3 main drive chips on here. And you know, this one here might well be the, you know, the current source for driving the brushless DC motor, for example. A lot of these, you know, the modern hard disks have now been replaced largely with SATA, so you don't see these, you know, big old connectors any longer, because the serial ATA is the more modern method of talking to hard disks, and supports these very high density hard disks that we get today. So there's a bit of foam there, a bit of insulation between the hard disk drive controller and the case. There's a sticker there, which obviously if you peel that off, you have a hole in the casing. So again, maybe something to do with gas filling it. I'm not really sure. And there's another little port on the side there, which if you took that sticker off, you'd have a hole in the side, and you'd no longer be, you know, sort of no longer have integrity to stop the dust getting in there. But these are quite nice. You know, I think this is aluminium. It's a big solid piece of metal anyway, and that's the, you know, the main physical structure of the hard disk. Okay, hope you found that interesting. That's all I'm going to look at today, and so I'll see you in the next video.